So hi everybody. In the previous class we have discussed regarding the what is magnetostatics, and based on the magnetostatics, so we have proved one theorem. So in magnetostatics the Lorentz force is rotational and J lines and B lines are lies on the surface. P plus omega is equal to constant. Then we have discussed regarding force-free magnetic field. So yesterday I told you force-free magnetic field means the Lorentz force J cross B is equal to 0. Is it right? The Lorentz force J cross B is equal to 0. It means that both the current lines J and the magnetic field lines are parallel, right? So using this concept, so we have proved one equation, del cross B is equal to alpha into B. So we proved one equation, del cross B is equal to alpha into B, where alpha is proportionality constant. The speciality of the proportionality constant alpha is it must be either a purely a constant or must be a function of both position and time. Function of both position and time, or it must be purely a constant. Okay. Now today I am going to derive the basic equations of force-free magnetic field. Okay. Force-free magnetic field. Right. The basic equations of force-free magnetic field. Now, so by the definition of force-free magnetic field, as you know, yesterday we proved it, del cross B is equal to alpha into B. Yesterday we proved this equation. Call this equation as number 1. We know from the property of the vectors, that is divergence of curl of any vector is equal to 0. Is it right? Divergence of curl of any vector must be equal to 0. Right. So using this property, by applying divergence on both sides of equation 1, you are going to get divergence of alpha into B is equal to 0. Because, so by taking divergence to here, this term will become 0 using this property. That's why the remaining is divergence of alpha into B is equal to 0. Okay. So again, using the vector identity, I am going to expand this as scalar into divergence of B, okay, scalar into divergence of B plus B dot gradient of alpha, B dot gradient of alpha, but this total quantity must be equal to 0, is it? So therefore, so illi you know from the solenoidal property del dot B is equal to 0. It is from the solenoidal property, that is del dot B is equal to 0. So that's why the remaining is, so B dot gradient of alpha is equal to 0. Call this equation as number 2. Right. So this equation shows that alpha is constant along magnetic field line. Okay. So this shows that alpha is constant along magnetic field lines. However, its value can change from one field line to another field line. Means alpha value can change from one field line to another line. Right. Now, so magnetic induction equation for the magnetostatics. Magnetostatics means the velocity term must be 0. For that you have derived the magnetic induction equation, that is in the form del B by del T is equal to nu m into del square B, because so del cross Q cross B is equal to 0 agutte, because the velocity term is 0. That's why the magnetic induction simply is given by like this. So from the vector identity, you know, curl of a vector is equal to, gradient of divergence of B minus Laplacian of B ಅಂತೇಳಿ Laplacian of B ಅಂತೇಳಿ ನಾವು ಒಂದು ವೆಕ್ಟರ್ ಐಡೆಂಟಿಟಿ ನಮಗೆ ಗೊತ್ತಿದೆ. ಏನು? curl of B is equal to gradient of divergence of B minus Laplacian of B ಅಂತ. but this term tends to 0 because del dot B means, so your solenoidal property, that's why this term will is equal to 0. Therefore the remaining is curl of B is equal to minus Laplacian of B ಅಂತ ಉಳ್ಕೋತು ನಿಮಗೆ, right? Now, so if we are going to substitute this term, means Laplacian of B in the magnetic induction equation like this, del B by del T is equal to nu m into del square B. So one can get, so ಏನು ಬರುತ್ತೆ ನಿಮಗೆ, del B by del T is equal to minus nu m into curl of B, curl of B, right? But from equation 1, you know, from equation 1 andre idu alva, ಇಲ್ಲಿ ಏನು ಹೇಳುತ್ತೆ, equation 1 says curl of B is equal to alpha into B. By substituting here, using that equation here, you are going to get del B by del T is equal to minus nu m into curl of alpha into B. Curl of alpha into B. Using equation 1, you can write like this. Okay. Now again, so you can use the vector identity, that is, curl of alpha into B can be written as alpha into curl of B plus gradient of alpha cross B ಅಂತೇಳಿ. ಇಲ್ಲಿ ಡೈವರ್ಜೆನ್ಸ್ ಹೆಂಗ್ ಉಪಯೋಗಿಸ್ಕೊಂಡ್ರಿ ವೆಕ್ಟರ್ ಐಡೆಂಟಿಟಿನ, ಸೇಮ್ ಪ್ಯಾಟರ್ನ್ ಅಲ್ಲಿ ನಿಮಗೆ ಕರ್ಲಿಗೂ ಕೂಡ ಒಂದು ವೆಕ್ಟರ್ ಐಡೆಂಟಿಟಿ ಇದೆ, ಫ್ಲೂಯಿಡ್ ಮೆಕ್ಯಾನಿಕ್ಸ್ ಅಲ್ಲಿ ಓದಿದ್ದೀರಾ. ಸೊ ದಟ್ ಈಸ್ ಗಿವನ್ ಬೈ ಲೈಕ್ ದಿಸ್, ರೈಟ್? ನೌ, ಸೊ ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದಿಸ್ ಟರ್ಮ್ ಇನ್ ದಿಸ್ ಈಕ್ವೇಶನ್, ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ del B by del T is equal to minus nu m into alpha into curl of B plus gradient of alpha cross B. Is it right? You can write like this, right? So ಈಗ nu m ನಾನು ಈ ಸೈಡ್ಗೆ ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋತೀನಿ. 1 by nu m into del B by del T is equal to alpha into del cross B ಅಂದ್ರೆ del cross B ಅಂದ್ರೆ equation 1 ಏನ್ ಹೇಳುತ್ತೆ, del cross B is equal to alpha into B ಅಂತೇಳಿ equation 1 ಹೇಳುತ್ತೆ ಅಲ್ವಾ? ಸೊ ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದಟ್, ಅವಾಗ ಏನಾಯ್ತು, ಆಲ್ಫಾ, ಇದು ಮೈನಸ್ ಸೈನ್ ಇದೆ, ಮೈನಸ್ ಸೈನ್ ಆಲ್ಫಾ ಸ್ಕ್ವೇರ್ ಇಂಟು ಬಿ ಆಯ್ತು. ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್, ಸೊ curl of B as alpha into B, you are going to get minus alpha square into B plus, minus, ಯಾಕಂದ್ರೆ ಥ್ರೂಔಟ್ ಮೈನಸ್ ಇಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೋಬೇಕು, ಮೈನಸ್, ಸೊ gradient of alpha cross B ಅಂತ as it is ಬರೀತೀನಿ, right? Now again this equation can be written as, so 1 by nu m into del B by del T is equal to, instead of writing, as you know, cross product is not commutative. A cross B can be written as minus B cross A anta baribodu, because cross product is not commutative. That's why this term can be written as B cross del alpha, right? Minus, so remaining term is alpha square B anta baritini. Remaining term is alpha square by alpha square into B. ನಾನೊಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ತಗೊಳ್ತೀನಿ. ಏನು, ಇಫ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ದ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್, ಟೌ is equal to some nu m into t, tau is equal to some nu m into t, then so this term can be written as, ಈ ಟರ್ಮ್ ಏನಂತ ಬರೀಬಹುದು ನೀವು, you can write it as del B by del tau ಅಂತ ಬರೀಬಹುದಾ ಇದನ್ನ, del B by del tau, this is equal to del B by del tau is equal to B cross del alpha minus alpha square into B ಉಳ್ಕೊಂತು. Okay, so now, so equation 1 ಏನ್ ಬಂದಿತ್ತು, curl of B is equal to alpha into B ಅಂತ ಬಂದಿತ್ತು. equation 2 ಏನ್ ಬಂದಿತ್ತು, so equation 2 as B dot gradient of alpha is equal to 0 ಅಂತ ಬಂದಿತ್ತು. And now you have equation 3 like this. Now you have equation 3 like this. And these three equations are known as basic equations of force free magnetic field. This equation, this equation, right, and then this equation. These three equations are called as basic equations of force free magnetic field. Okay, ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಬಹುದು derive the basic equations of force free magnetic field ಅಂತೇಳಿ. Then you have to write all these things, right? So using the definition of basic force free magnetic field, curl of B is equal to alpha into B ತಗೊಂಡು so ಇಲ್ಲೇನೇನು ಪ್ರೋಸೆಸ್ ಮಾಡ್ಕೊಂಬಂದೆ just so using the vector identity you are going to reduce the equation to another form, and finally you obtain these three equations are called as basic equations of force free magnetic field ಅಂತೇಳಿ ಕರಿತೀನಿ. Now I am going to prove some examples. I am going to prove some examples. Look here. For force free magnetic field, right, for force free magnetic field you have to prove first one, alpha is equal to B dot curl of B divided by mod B whole square. Okay, so alpha is equal to, you can express alpha in this form. And second, you are going to prove, so alpha is equal to curl of B dot curl of B whole divided by curl of B whole square. So for a force free magnetic field B, so alpha can be written in this form, and also alpha can written in this form also ಅಂತೇಳಿ ನೀವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. Now I am going to prove first one. So B dot curl of B divided by B square ಅಂತೇಳಿ ಪ್ರೂವ್ ಮಾಡಬೇಕು. So what is this? This is nothing but your alpha, right? Now from the definition of force free magnetic field, from basic equation, you know that curl of B is equal to alpha into B. This is known thing. This is the first basic equation of the force free magnetic field. Now I am going to take dot product of B on both sides of this equation. Dot product of B, then this will become, so B dot curl of B is equal to alpha B. So dot, B dot alpha B. Left hand side in the counter, left hand side, right hand side in the counter, right. No problem, because dot product is commutative, right? So B dot curl of B is equal to B dot alpha into B height, right? Now, so B dot alpha is scalar, right? B dot B becomes B square. It implies, so alpha into mod B square is equal to, so it is as it is, B dot curl of B. Okay, therefore what is your alpha? Alpha is equal to B dot curl of B divided by, so mod B square. So by simplifying this equation you are going to get this one. Okay, now go for the second one. Alpha can be written in this form. For that also you have to consider the same equation, curl of B is equal to alpha into B, right? Now I am going to take curl on both sides of the above equation. ಯಾಕೆಂದ್ರೆ curl ಇರೋದ್ರಿಂದ ಇಲ್ಲಿ, so I am going to take curl on both sides of the above equation. Then that will become curl of B is equal to curl of alpha into B. Right? But ನಿಮಗೆ curl of alpha into B ಅಂತಂದ್ರೆ, that's why curl of, right? So curl of B is equal to, so curl of ಅಂದ್ರೆ ಏನು ಬರೀತೀರಪ್ಪ, alpha into curl of B, okay, plus gradient of alpha cross B ಅಂತ ಈಗ ತಾನೇ ಉಪಯೋಗಿಸ್ಕೊಂಡಿದ್ದೀವಿ ವೆಕ್ಟರ್ ಐಡೆಂಟಿಟಿ. ಆ ವೆಕ್ಟರ್ ಐಡೆಂಟಿಟಿನ ನಾನು ಬರದೆ. Now, so to this I am going to take the dot product of curl of B on both sides. ಇದು ಎರಡು ಸೈಡ್ ಮೇಲೆ ನಾನು ಏನು ತಗೊಳ್ತೀನಿ, I am going to take the dot product of curl of B on both sides. Then this will become, ನಾನು ಈ ಸೈಡ್ ನ ಈ ಕಡೆ ಬರ್ಕೋತೀನಿ, ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್, ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಅಲ್ಲಿ ಏನಾಯ್ತು, ಆಲ್ಫಾ ಇಂಟು, ರೈಟ್, ಸೊ ಇಲ್ಲಿ curl of ಬಿ ಇದೆ. ಈ ಡಾಟ್ ಪ್ರಾಡಕ್ಟ್ ಕರ್ಲ್ ಆಫ್ ಬಿ ತಗೊಂಡ್ರೆ ಆಯ್ತು ಮಾಡ್ಯುಲಸ್ ಕರ್ಲ್ ಆಫ್ ಬಿ ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಆಯ್ತು ಪ್ಲಸ್ ರೈಟ್. ಸೊ ಇಲ್ಲಿ ಇದು ಟರ್ಮ್ ಏನಿದೆ, ಸೊ ಯು ಕ್ಯಾನ್ ರೈಟ್ ಕರ್ಲ್ ಆಫ್ ಬಿ ಡಾಟ್ ದ ಗ್ರೇಡಿಯಂಟ್ ಆಫ್ ಆಲ್ಫಾ ಕ್ರಾಸ್ ಬಿ ಅಂತ ಬರೆದ್ರಿ ಅಲ್ವಾ, ಈ ಟರ್ಮ್ಗೆ is equal to curl of B, okay, dot curl of B ಅಂತ ಬರದೆ, curl of B ಅಂತ ಬರದೆ, right. Now again upon simplification ಏನ್ ಬರಿಬಹುದು, again it is curl of B modulus of curl of B whole square plus ಇಲ್ಲಿ ಕರ್ಲ್ ಆಫ್ ಬಿ ಇದೆ ರೈಟ್. ಕರ್ಲ್ ಆಫ್ ಬಿ ನೀವೇನಂತ ಬರೀಬಹುದು, ಯೂಸಿಂಗ್ ದ ಡೆಫಿನೇಷನ್ ಆಫ್ ಇಲ್ಲಿ ನಾವು ಈಕ್ವೇಶನ್ ಉಪಯೋಗಿಸ್ಕೊಂಡಿದೀವಲ್ವಾ, ಕರ್ಲ್ ಆಫ್ ಬಿ ಕ್ಯಾನ್ ಬಿ ರಿಟರ್ನ್ ಆಸ್ ಆಲ್ಫಾ ಇಂಟು ಬಿ ತಗೊಂಡೆ. ಅವಾಗ ನೋಡಿ ಇಲ್ಲಿ ಏನಾಯ್ತು, ಆಲ್ಫಾ ಇಂಟು ಬಿ ಡಾಟ್, ಸೊ ಗ್ರೇಡಿಯಂಟ್ ಆಫ್ ಆಲ್ಫಾ ಕ್ರಾಸ್ ಬಿ ಆಯ್ತು. ಓಕೆ, ಸೊ ಇಸ್ ಈಕ್ವಲ್ ಟು ಇಟ್ ಈಸ್ ಆಸ್ ಇಟ್ ಈಸ್ ಕರ್ಲ್ ಆಫ್ ಬಿ dot curl of B, right. Look here, so here remaining is alpha into modulus of curl of B whole square. So here look here, illi A dot B cross C form alli ide. You can also write it as, nimge ಏನು one time ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, using vector property A cross C ನು ಆಗುತ್ತೆ ಇದು ಅಲ್ವಾ. A cross C ಆದಾಗ ನೋಡಿ ಇಲ್ಲಿ B cross B ಬರುತ್ತೆ ನಮಗೆ. B cross B ಅಂದ್ರೆ ಸೇಮ್ ವೆಕ್ಟರ್ ಇರೋದ್ರಿಂದ ಕ್ರಾಸ್ ಪ್ರಾಡಕ್ಟ್ ಏನಾಗುತ್ತೆ, ಇಟ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0. ದಟ್ಸ್ ವೈ ದಿಸ್ ಟರ್ಮ್ ಟೆಂಡ್ಸ್ ಟು 0. ನಿಮಗೆ ಬಿ ಡಾಟ್ ಇಲ್ಲಿ ಬಿ ಕ್ರಾಸ್ ಬಿ ಬರುತ್ತೆ, ದಟ್ಸ್ ವೈ ದಿಸ್ ಟರ್ಮ್ ಮಸ್ಟ್ ಬಿ ಈಕ್ವಲ್ ಟು 0. therefore remaining is curl of B dot curl of B ಅಂತ ಬಂತು, curl of B. ನಿಮಗೆ ಬೇಕಾಗಿರೋದೇನು ಆಲ್ಫಾ, therefore alpha is equal to curl of B dot curl of B, okay, whole divided by modulus of curl of B whole square anta bantu. Now so we have proved both the equations. For alpha is equal to like this also and alpha is equal to like this also, using the definition of force free magnetic field, right. Now so again they have given, if B is equal to gradient of phi plus chi into gradient of eta, gradient of phi plus chi into gradient of eta, the magnetic field B is defined like this and is force free magnetic field. This B is force free magnetic field. Then we have to prove your alpha is given by gradient of phi dot gradient of chi cross gradient of eta divided by modulus of gradient of phi whole square minus chi square into modulus of gradient of eta whole square anta, right. So if the magnetic field B is like this, defined like this, and it is force free magnetic field, then you have to prove alpha is given by in this form. Okay, so now where phi, eta and chi are arbitrary scalars. Okay, these are all arbitrary scalars. Now given, so we have to prove B is equal to gradient of phi plus chi into gradient of eta. Okay, call this equation as some 1. Now by taking curl on both sides, you are going to get curl of B is equal to curl of gradient of phi plus chi into gradient of eta. Is it right? So now look here, you can write it as curl of gradient of phi by expanding this, and upon operating on this you are going to get curl of chi into gradient of eta. What about this term? This term must be 0 because curl of a gradient is 0. Right. Therefore, the remaining is, so look here, curl of B means alpha into B. Is it right? From the, basic equation of the force free magnetic field, curl of B can be written as alpha into B. This is equal to alpha into B is equal to, so look here, you can write it as curl, gradient of chi cross gradient of eta. You can write this as gradient of chi plus gradient of eta. By expanding this, you are going to get this one. Now by taking the dot product of the term gradient of phi minus chi into gradient of eta on both sides of this equation, you have to take the dot product of this term on both sides of this equation. You are going to get alpha is constant, right? So gradient of phi minus chi into gradient of eta, right? Dot B, because you are taking dot product. So this is equal to gradient of phi minus chi into gradient of eta dot gradient of chi cross gradient of eta. Now look here. So you defined it, B is equal to this one. B is equal to this one. So what is that? This is nothing but alpha into, it is as it is, gradient of phi minus chi into gradient of eta dot B and substitute ಮಾಡ್ತೀರಾ, gradient of phi plus chi into gradient of eta, because B ಅಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ, ಈ ಟರ್ಮ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ರೆ is equal to, right hand side is given by gradient of phi dot, expand ಮಾಡ್ಕೋತೀನಿ, so gradient of chi cross gradient of eta, right, minus chi into gradient of eta dot, so gradient of chi cross gradient of eta. Okay, chi into gradient of eta dot gradient of chi cross gradient of eta. But one time ಏನಾಗುತ್ತೆ ಇದು, so gradient of eta cross gradient of eta ಆಗುತ್ತೆ. ಅಂದ್ರೆ same vector ಏನಾಯ್ತು, cross product of two vectors becomes, same vector becomes ಏನಾಯ್ತು, 0 ಆಗುತ್ತೆ. Therefore the remaining is, this is equal to like this. But ಇಲ್ಲಿ ಏನಾಗುತ್ತಪ್ಪ ಅಂತಂದ್ರೆ, so look here, ಇಲ್ಲಿ ಇದು ಎರಡು ಟರ್ಮ್ a minus b, ಇದು a plus b ಫಾರ್ಮ್ ಅಲ್ಲಿ ಇದೆ. ಹಾಗಾದ್ರೆ ಏನ್ ಬರೀತೀರಾ ಇದನ್ನ, so a square minus b square ಅಂತ ಬರೀಬಹುದು. So by writing like that, you are going to get alpha into modulus of gradient of phi whole square, ಇದು okay, minus chi square, right, into gradient of d eta square is equal to same RHS ಏನು, so gradient of phi dot gradient of chi cross gradient of eta, right. ನಿಮಗೆ ಬೇಕಾಗಿರೋದು ಏನೀಗ, ಆಲ್ಫಾ ಬೇಕು ಅಂದ್ರೆ ಈ ಟರ್ಮ್ ಏನ್ ಮಾಡಬೇಕು, you have to cross multiply. By cross multiplying this, you are going to get, what you are going to get, the required, alpha is equal to gradient of phi dot this divided by, so same term, right. So this is about the problem. So next so we have to prove one theorem. So I am going to prove that theorem in the next class, because so that will take little time. So that's why it is better to stop here. ನಿಮಗೂ ಜಾಸ್ತಿ ಆಯ್ತು ಅಂತಂದ್ರೆ ಡೈಲಿ ಕೇಳಲಿಕ್ಕೆ ಬೋರ್ ಆಗ್ಬೋದು, ಒಂದು 20-25 ನಿಮಿಷ ಆದ್ರೆ ಬೆಟರ್ ಅನ್ಕೋತೀನಿ. ದಟ್ಸ್ ವೈ, so I am going to stop here. Take care. Thank you.